this is what you should use as you're analyzing your where is it? Your project, okay? So think about, these are basically, this is kind of a review of chapter 9. Why can't I find what I'm looking for? Here it is. Chapter 23 is use and abuse of statistics. Okay? So, some questions that you should, so whether you're reading your study or someone else's study, the question you should ask yourself is, where does the data come from? Okay? It's a very important question you should be asking yourself. Okay? Now, as I mentioned, number one, it must, the rules state, the hypothesis test / confidence interval rules state it must come from a simple random sample. Okay? Now, in practice, as you guys have found, in practice this is difficult. Okay? So in practice you may choose to do some other kind of a thing, such as convenience, although convenience is really a bad option. But stratified is actually a pretty good option, but technically it doesn't work with stratified, etc. All those other options that we have out there, you might use those in order to collect data. So number two, complex designs, complex methods don't work with hypothesis tests and confidence intervals, so your results are open to challenge. Okay? Now, number three, there is no method to fix haphazard data collection. If you've got bad data, you've got bad data. You can't just fix it. Okay? I'll give you a true story that happened to me, and it was a terrible thing. I was a junior in college, like, who's a junior in here? Like Emily and Trista.
I am.
Okay? So I decided I wanted to run for student senate at Weber State. Senate for Senate, isn't that a great slogan? And do you guys remember, are you too young to remember Al Gore and George Bush in 2000?
Yes.
Okay, the hanging chads. Okay, I did this back in the 90s. So it was a similar type of problem. If you remember George Bush and Al Gore, there was a lot of people that voted for Pat Buchanan because the ballot was really stupid. It was poorly designed. Okay, so a lot of people voted for the wrong person. Well, that's exactly what happened in my election. It used to be at Weber State, you could pick a senator at the Natural Science Department, you could pick a senator in the English department, you could pick all these different senators. Well, they changed the rules this year and didn't really tell anybody, and you could only pick one senator out of everybody. So of the, I think 1,100 ballots cast, 1,100, they threw out 1,000 of them. I lost like 71 to 35. Okay? I appealed to the Supreme Court, the Weber State Supreme Court, and they said, well, just because the ground's wet doesn't mean that they're, the rain. Could have been the sprinklers. So they ruled against me, and I was like, there's no way anybody would make a stupid rule like that. And then Al Gore and George Bush happened to do that, and I was like, wow, the Supreme Court really is stupid. Anyway, I went to my statistics teacher, because I was taking statistics like many of you, although it was a little bit tougher of a class. And I said, could you help me figure out the margin of error for this when they threw out 1,000 votes? And you know what he said to me? What do you think he said?
No.
He said, no. I'm like, no, you're a statistics teacher. You're supposed to figure this out. And he goes, you can't fix bad data. You can't fix it. It's bad data. You throw out 1,000 out of 1,100 votes. Sorry, Charlie, I can't fix that. It's bad. Okay? You can't fix bad data. Also, one other thing here, dropouts and non-response are important. Now, I know I've mentioned this before, but that's part of the reason why when we did this first project, in Project 1, I wanted you to figure out what was the response rate, okay? Some of you misinterpreted that. I wanted to know how many people responded, not how many people said yes. That's not the response rate. The response rate is how many people said yes, how many said no, how many people said, I'm not going to answer your question, okay? Now, in some cases, you'll notice your response rate was high. If you went into your class, it was convenient sample here, fill out my survey, you probably had 100% response rate. That's nice. How many of you had 100% response rate on your phone poll? Okay? It was probably pretty dismal. Okay? The problem is when you don't know how all those people who refuse to answer the phone, or if they answer the phone, refuse to talk to you, they're probably different than the people who responded in your class. Okay? They probably have different opinions. And so this introduces bias, but the problem is because they didn't respond, you don't know if your bias is too high or too low. It's important, but you have no way of knowing. Okay? So that's why response rates and dropouts are very important. Okay? Let's talk a little bit about confidence intervals. Okay? Number one, we never know if our confidence interval contains true parameter. Either it does or it doesn't, but we know it works. If it's a 95% of the confidence interval, it works 95% of the time, which means it fails 5% of the time. Okay, now, by the way, I'm going to open up this, I did a presentation for Math Week, and I thought, you know what, I should save this for my class, and so you guys are the first ones that are actually going to see this. I need to, Patriots don't fumble. So none of you came to my wonderful presentation. Have I told you guys that I work for ESPN? Okay. So that was a picture of me. I can't remember the announcers, but these are the announcers. I don't normally get to sit courtside, so I was like, wow, this is cool. So you can see there, ESPN behind us, Corey, and I don't remember that other guy's name. But anyway, this is the BYU NIT game not too long ago. Samane, she teaches here at UVU. She was like, this is inside the TV truck. My brother got me started in sports, that's him. Ryan, if we have time, I'll show you my clip. But the interesting thing that I just want to talk about is 538.com. Okay, you guys have heard of 538.com?
Yes, you showed us.
Do you know why it got its name, 538? Okay, back in the 2012 election, they correctly predicted all 538 electoral college votes exactly right. They said Mitt Romney was going to get whatever he got, and they said Barack Obama was going to get whatever he got, and they nailed it. They didn't do so good on 2016. But their claim to fame in 2012 was they nailed it. Now, they missed on the Trump-Clinton election. The day before the election, this comes from, it was either CNN or NBC, I can't remember which one it was. I can't remember which one it was. I think it was CNN, because they had said that Hillary Clinton had dropped below 270 for the first time. And they were like, she might not win. They were sure she was gonna win until then, but even here, she was winning. This is the day before the election. They predicted she was gonna win 268 to 204, but they had 66 votes undecided, which are the yellow states. So Nevada, Arizona, Florida, North Carolina, and New Hampshire were the states that they said it was too close.